When I start the car, I start the movement of energy inside my car. The kinetic energy comes from the energy supplied by the car converting electrical stored energy to kinetic energy via engine. Some people say that the energy comes from inside the car while the momentum comes from outside the car. That is true. This can be applied to the equation k equals mass times velocity squared divided by 2. Also, some of the kinetic energy is converted to gravitational potential energy as you're moving the vehicle farther away from the center of Earth. The formula is mass times height times acceleration due to gravity, which is 9.8 newtons. You know that. Newton's first law can also be applied to this situation, because if there's no outside force acting upon the car to start the engine, then the car will not start. It's pretty simple. That's it.
To calculate the velocity of this pitch, we're going to use the equation x final minus x initial over t final minus t initial. The mound is 60 feet 6 inches away from home plate, which is equivalent to 18.44 meters. My stride towards home plate is 71 inches or 1.8 meters. I release the ball just over the foot I have strided with. To find the exact point when I release the ball, we need to subtract the distance of the mound to home plate by the length of my stride towards home plate. We would do 18.44 meters subtracted by 1.8 meters, and we would get 16.64 meters. The time it takes the ball to reach home plate from the point of release is 0.41 seconds. Now, using this information, we can plug in the numbers we know into the formula I mentioned before. X final equals 16.4 meters, X initial is 0 meters, T final equals 0.41 seconds, and T initial is 0 seconds. Now we would divide 16.64 meters by 0.41 seconds and we would get 40.59 meters per second, or 90.8 miles per hour.
I will start by dropping two similar masses at the same time to simulate how objects with no air resistance occurring on them would drop at the same time. This is because the acceleration due to gravity is constant for all objects regardless of mass according to Newton's law, but that's of course more neglecting air resistance. It only depends on the mass of the Earth, but when the force of the object exerts when it hits the ground, it varies with its mass. The reason this happens is because of gravity. Well, of course, the gravitational pull on all objects to the ground. But Newton's law says force is equal to mass times acceleration, which I said earlier. So the two objects should technically hit the ground at different times. But of course, that's only true when we're neglecting air resistance.
Using this incredible situation that ended up with me getting $20 from some of my friends, we could find the gravitational potential energy and the momentum. The equation for gravitational potential energy is GPE equals mgh. M equals mass, G is the gravitational field strength, which is 9.8 newtons per kilogram on Earth, and H is the height. At this point I'm about 8 feet in the air, which is equivalent to 2.44 meters. I weigh about 180 pounds, which is 81.6 kilograms. Now we need to multiply 81.6 kilograms, 9.8 newtons per kilogram, and 2.44 meters, and we end up with an answer of 1,951.22 joules. We can also find the momentum using the equation momentum equals mass times velocity, or P equals mv. We already know my mass of 81.6 kilograms, so we could plug that in, and I was traveling at 2.7 meters per second, so we could plug that in for the velocity. Now if we multiply the two numbers together, we end up with an answer of 220.32 kilogram meters per second.